In this chapter, we'll take a look at the TivaWare Sensor Library and the Tiva Sensor Hub. The Tiva Sensor Hub BoosterPack features 9 axes of motion and multiple environmental sensors. BoosterPack XL connectors allow direct connection with the TM4C 123GXL and LM4F 120GXL LaunchPads and hardware compatibility with other LaunchPad boards. EM connectors are provided to allow boards like the CC3000 Wi-Fi or other TI RF connectivity boards to be attached. The board adds 2 buttons and 2 LEDs when connected to the LaunchPad. Unique applications are provided for each sensor, and an airmouse application demonstrates fusion of the motion sensor inputs. Support is provided for Code Composer Studio, Kyle, IAR, and Sorcery CodeBench IDEs. The TivaWare for C-Series sensor library is distributed for use using the BSD style licensing. Cost of the Tiva Sensor Hub is $50 US. U1 is TI's TMP006 infrared temperature sensor. This no-contact device can measure temperatures over a 40 to 125 degrees centigrade range. The supply current is 240 microamps, and the supply voltage can be between 2.2 and 7 volts. The device has an I2C interface with address 0x41. During operation, the ambient temperature of the IR pile and the observed temperature of the target are communicated over the serial interface. These 2 measurements are then used by a sensor library API to calculate the actual temperature of the target. U2 is the Bosch BMP180 digital pressure sensor. It has a measurement range of -500 to 9,000 meters mean sea level and a temperature sensor for altitude compensation. Supply current is 5 microamps at 1 sample per second, and the supply voltage can be between 1.8 and 3.6 volts. The sensor is designed for very low noise and has multiple sampling modes to trade off between power and accuracy. The device has an I2C interface with address 0x77. A sensor library API calculates the altitude from the raw pressure and temperature data. U3 is the Invensense MPU 9150 9-axis motion sensor. It combines 3 MEMS sensors in a single package: a 16-bit resolution 3-axis accelerometer, a 16-bit resolution 3-axis gyroscope, and a 13-bit 3-axis magnetometer or compass. The device has an I2C interface with address 0x68. Supply voltage is between 2.375 and 3.465 volts. U4 is the Intersil ISL 29023 ambient and infrared light sensor. The device has 16-bit resolution plus 50 and 60 Hz flicker rejection to eliminate fluorescent bulb noise. Supply voltage is 1.7 to 3.63 volts. The device has an I2C interface with address 0x44. The device can provide interrupts, both hardware and software, at programmed light levels. U5 is the Sensirion SHT21 humidity and ambient temperature sensor. Humidity is measured with 8 or 12-bit resolution, while temperature is measured with 12 or 14-bit resolution. The supply voltage can be between 2.1 and 3.6 volts. The device has an I2C interface with address 0x40. Slots are provided in the board for air circulation. The direct cosine matrix or DCM algorithm is used to combine or fuse the multiple axes into a single set of Euler angles representing the orientation of the body with respect to the Earth. The final calculated orientation is less prone to dropout and of higher accuracy than the best individual sensor. Rotational matrices and vector math are used by the sensor library's APIs to calculate these angles. The 3 sensors used in this algorithm are all within the Invensense device. The 3-axis accelerometer measures the gravitational field of the Earth minus any acceleration. The 3-axis magnetometer measures Earth's magnetic field and the 3-axis gyroscope measures angular velocity. In the DCM algorithm, the gyroscope is the primary sensor. It's unaffected by Earth's gravity or magnetic field, but any gyroscope is prone to drift over time. The accelerometer provides orientation in the X and Z axes and compensates for roll and pitch errors. The magnetometer provides a reference vector in the Y-axis and compensates for yaw errors. The magnetometer and accelerometer are used to calculate a proportional feedback to remove the drift of the gyroscope. The airmouse example demonstrates the DCM algorithm in use by creating a human interface device, computer mouse, that can be used to move the on-screen cursor. The Invensense sensor provides 9 axes of measurements, which are then fused and filtered using the DCM algorithm to calculate the Euler angles for roll, pitch, and yaw. The roll and pitch angles are used to perform the mouse movements. Angular velocities and accelerations are used to interpret gestures. The angles and the movements are calculated 100 times per second. In Lab 14A, you'll install the Sensor Hub onto your LaunchPad board and then program the airmouse binary file into flash memory using the LM Flash programmer. Then you can experiment with the application. The sensor library contained in TivaWare has the following features. It has drivers for the I2C port and all 5 sensors. It has functions for manipulating and correcting the compass readings. The comp under DCM example reads the sensors and applies the DCM algorithm to the data. The library contains several APIs for easily handling vector math operations. The sensor library provides a consistent programming model with the flow shown for all sensors, making it easy to leverage the library for other custom I2C sensors. The example shown is for the TMP006 IR temperature sensor. First, the I2C peripheral and its pins must be configured. Second, the I2C driver can be initialized. Third, the TMP006 can now be initialized across the I2C connection. Fourth, the TMP006 can be properly configured. At this point, data can be read from the device and converted into a temperature reading. Included Sensor Hub examples are airmouse, which shows off the DCM algorithm, comp DCM under MPU 9150, which demonstrates basic data gathering from the MPU 9150, drivers for the buttons and LEDs, humidity under SHT21 to perform periodic measurements of humidity, light under ISL 29023 that uses measurements of the ambient light to control the LaunchPad LED, pressure under BMP 180 to demonstrate air pressure and temperature measurements, temperature under TMP006 to periodically measure and calculate the temperature of an object. In Lab 14B, you'll write a sensor application from a blank page. You'll use the ISL 29023 and display the raw ambient light levels in Code Composer. Then you'll experiment with visualizing the data using a new tool called GUI Composer.